Alright, this is a little quick video about how to do the logistic growth curve for our beetle data in ecology lab. Alright, so this is these are our data. We have a total of 12 or 16 populations, and there are 6 different times that we collected the number of beetles in a population, which are these data here. Some of these data are real, some of them are made up. It doesn't really matter. So to keep things simple, let's copy the date and stick it over here. It'll be much easier if we do that. Okay. Now, when you report it, you don't want to report just the date. You want to give it something simpler and more clear. So let's make it day. This is going to be day 0 for the first one. Okay. And for the second one, we want the difference between this one and this, so it should be equals that minus that. Alright, so that's 14. Now if we just copy this throughout, what we do is we're getting the difference between this one and this one, and that one and that one. That's not what we want. We want the difference from this to the very beginning and this one to the very beginning. So what we can do is we can come here, select S2, which is our first cell, and we hit the F4 key, or just manually add a bunch of $signs, and the $signs are going to keep those values from changing. So if we look at this one, this equation is this one minus this one. Okay, and if you look at this one, the equation is this cell here minus that cell. So the S2 never changes because of the $signs. Okay, then what do we want next? We want to calculate the mean size of each population. So it's the average of all of these for this particular day. We don't want to get the day in there. So that's our mean. Copy that, paste that down there. Alright, we're going to want something else here. I'm not going to tell you what it is just yet. And then over here, let's put the standard deviation. Okay, standard deviation. We want this one, the sample standard deviation. Oops. And we don't want those numbers in there. But we want the standard deviation for all of these samples. The first one is going to be 0 because they're all starting off at 10. And we paste that there. Alright, what we're trying to do is we're trying to look at the logistic growth curve as it applies to these beetles. So this is what we're going to want to put in this column. So I'm just going to put LOG models for the logistic model. Alright, what is the logistic model? So it's a way to predict and understand the growth of a population over time. I just so happen to have the equation right here. Alright, so what does this all mean? P at time t, which is the size of the population at time t, is going to be equal to K, which is the carrying capacity, times P at time 0, which is the population at time 0, times e to the RT. E is just the general exponent, right? It's related to natural log. R is the the intrinsic rate of growth of the population, and T is the time T. And that's all divided by K plus P sub 0 times this value here in parentheses. So that means we need to establish what our R is. Let's put R is equal to here and K here. And let's just for now, let's put in the value of 0.5 for R and 100 for K. We'll modify those later. So the logistic growth model, we're going to start off here with 10. Because we all started with 10. And now for this data point, let's put in the equation. And this is where the equation is going to be a bit complicated, so pay attention. It's going to be equal to, start our parentheses, K, and let's hit F4, so we get dollar signs because we don't want that to change, times population at 0, hit F4 again, times, and then how do we do this? We do EXP with parentheses R, we don't want that to change, so we have the dollar signs, times T. Alright, so this is day 14, so that's our T. That one we do want to change as we go further forward in time, so we're not going to put any dollar signs around that. We close off our parentheses here. We divide that by K again, dollar signs, plus P sub 0, dollar signs, times exponent of R, dollar signs, times T, no dollar signs, minus 1. Put another parentheses there, one more parentheses there. It's all matched up. That is what our logistic model says. Alright. So, now, let's graph it. We don't want to graph date. We want to graph day, mean, and logistic model. So just click on those. I'm going to click on this. And we're going to use the curvy one. Generally, we don't use the curvy one, but for this case, we will. So let's use the smooth lines. Alright, there's a lot that's you have to fix with this figure. Access titles, get rid of all this junk, but I'm going to show you the critical things. This is the logistic model here, the orange line. We don't want these points. We want it to be one single smooth model. So we can select those points, go up here to Format, Series Log Model, format the selection. Come over here, we click on that, click on Marker, Marker Options. We don't want any markers. See you in hell, markers. They're gone. Okay. Alternatively, we don't want this line down here. We want just the points. So I'm going to click on this, format. It says series mean, format selection. We click on format selection. It was already open over here, but just showing you from scratch. We want no line, and then boom. Okay. One final element we want to add is we want to add the standard deviations. So again, we'll click on that. We'll click on design up here at the top, design, add chart element on the left, error bars, more error bar options. Opens up over here. We want vertical, both directions, and we want custom error bars. So we want to specify the value. The positive ones will be the standard deviation. The negative ones will also be the standard deviation. We hit OK, and now we see we got some pretty looking error bars there. Now you also see that we have these horizontal ones that Excel likes to stick in there without asking. So we just want to select it, right? So just click on the error bars, hit delete, and then they're gone. Beautiful. Beautiful, beautiful. And so now what you're going to do, number one, you got to fix the figure, make it look nice. Get rid of the chart title, the grid lines, etc., stuff you hopefully know by now. Don't leave this down here taking up space. You need access titles. But then this is what you're going to need to do. You're going to need to modify R and K so that this logistic growth model, which is the prediction made by this mathematical model here, fits the actual data, which are here. And then that way we can say what the R and the K are for these beetles. So let's say R, let's adjust that. Let's make it 0.2. Okay, doesn't really fit. Let's make it 0.1. Oh, that's getting a little better. Let's make it 0.05. Okay, it's getting a little better. Let's change our K. Let's make our K 80. Is that better? Is that worse? You decide. So you're going to want to modify these until you get as close as possible, and it might not fit perfectly, okay, but as close as possible to this. And then that's going to say, well, this is probably what our R and our K are. All right, that's it. Hope you enjoyed that.